Hi Year 11, welcome back. We're going to take our first peek inside Booklet F, and it opens up with identifying graphs, which we're going to do on another bit of paper just to give you a bit of background on that. Quite a new thing for some of you. Then the rest of this booklet we're going to take a look at the next four topics. Drawing an exponential graph, that's one of the graphs we'll have to identify in a minute. Drawing quadratic and cubic graphs, again more of the graphs that we're going to be showing you how to identify in a minute. Drawing straight line graphs, links back to there. And then I thought something that leads on quite nicely from straight line graphs is inequality graphs, where you're going to draw more than one straight line and kind of identify a region that satisfies lots of inequalities. Hopefully we get there in the next sort of 20 minutes maybe. Okay, I'm going to move this away for a sec though and talk you through some of these graphs that we're going to have to be able to identify. So let's start with some straight line graphs. Okay, straight line graphs have the form y equals mx plus c. That m gets replaced with a number, and the number that goes in there is the gradient. Okay, how steep the line is, and also whether it's a positive gradient going up or a negative gradient coming down. And the plus c, the number on the end there, is the y-intercept. You don't insert numbers for x and y. Okay, the equation of the line is y equals something x plus or minus something at the end. Okay, two examples for you. If I was asking you to look at this, hopefully you'd spot that that's got a positive gradient, so I'd be expecting a positive number there. But it cuts through the y-intercept down here on a negative number. So I'd expect this to be something like y equals something positive here, maybe, I don't know, 3, 4x, but something negative there, minus 2. Okay, whereas this one, let's do that. This one, I've got a negative gradient, but a positive y-intercept. So I would expect that to be something like y equals minus 3x, negative gradient, but a positive y-intercept, something like plus 5. Okay, so there are your straight lines, important things. Positive and negative gradients, positive and negative y-intercepts. Next type of graph are quadratic graphs. Now we know a quadratic to be y equals something x squared plus an amount of x's, let's put an a there, plus an amount of x's, plus a number on the end, okay? There may or may not be some x's, and there may or may not be a number at the end, but the important bit is the x squared. Anything with x squared looks like this. It has one bend in it. Okay, that graph there actually is y equals x squared. If it bends from the other direction, it comes from down, up and back down, it's minus x squared. Alright, so they are the two shapes to look out for: positive x squared graphs and negative x squared graphs. Okay, don't worry about the number of x's, all that does is it shifts it about a bit, but don't worry about that. But the other important number, if there is a plus c at the end, again, that plus c, like up here, that number, that loose number, is the y-intercept. So if I had something like this drawn, okay, and say that there is 3. This, the shape of it is a negative x squared, but it's got that y-intercept of 3, so I'd expect this to be something like minus x squared, and then I'd need that number there. If there's no number there, that would suggest it cuts through 0 like this. Another way of thinking I could have done here is written plus 0, suggesting that it has a 0 y-intercept. Okay, so quadratic graphs, we're looking for one bend, we're looking for y-intercept, alright, and plus x squared's bend this way and minus x squared's bend that way. Let's have a look at cubic graphs. This time y will be equal to something x cubed. Okay, again, there could be a number there. I'll use a to mean any number. There could be some x squareds, there could be some x's there. Alright, but I'm not worried about those. The other thing I'm worried about with a cubic is, again, what's that loose number at the end? That loose number, yet again, tells me where we cut through my y-axis. What is the y-intercept? If it's x cubed plus 4, it should cut a plus 4. If it's x cubed minus 4, it should cut through a minus 4. But what does a cubic look like? A cubic starts, grows, bends one way, and bends the other. Okay, if it came from the other direction, right? He would be minus x cubed as opposed to y equals x cubed. Again, if I'm looking in the exam and I've got something like this, okay, we've got that double bend. Actually, it's more pronounced here, because whereas this is kind of just fading away and then fading the other way, this actually is turning, changing direction and changing direction again, but it's still a double bend. But importantly, we've got this positive. If I put a 3 there, I'd expect this to be something like y equals, maybe a number, but the important bits is I get that x cubed and I get that plus 3 at the end. There may be other bits and bobs in there, like a number there or some x squared or whatever, but as long as I've got those two bits, he's likely to be that. Then come the slightly new ones here. Okay, we have one called an exponential curve, something like y equals 2, or could be 3, or could be 4 to the power x. The important thing is that x is the power, right? As we vary the x values, think about it, if x is 0, anything to the power 0 is 1. So these type of graphs will always go through 1. And they tend to, let's not get into too much detail here, but they tend to curve round, go through 1, and then curve up and grow exponentially, hence called an exponential curve. All right, we'll look out for a couple of those coming up. Another one is a reciprocal curve, something like this. And it never touches the x and y axis. Again, doesn't touch the x-axis there, doesn't there? It's in two parts, okay? Called the reciprocal curve, and we'll look like that. Maybe that's one just to learn off by heart, your exponentials and your reciprocals. Why have I put another one there? Okay, the other types that we're not going to look at in this booklet, but we've seen in other booklets, are our trigonometry graphs, like y equals sine x. Okay, something like that. Or y equals cos x, which does the same thing, but kind of is 90 degrees ahead of that one, and also tan x. But again, look back at those. I'm not going to go over those now. Right, let's get into the booklet. Everything I've just said is there. Okay, maybe I've given a bit more detail on that sheet and you want to transfer some of that detail over onto here, but this gives you an idea of what we're looking for. So let's go inside. Okay, here I've got to link the equation to the graph above, which I know you can't see a sec, but I've looked through these and I've made notes on what I'm expecting. This one is our, what am I saying? Sorry, I'm losing the plot. If I turn back to the front, sorry. This one is our reciprocal curve, okay, 1 over x. So I'm looking for that shape, and if you look above, that's graph E. This one, y equals 2x plus 3, that's a straight line. The number before x is 2, so positive gradient, and the number at the end is plus 3, so positive y-intercept. So straight line with positive gradient and positive y-intercept. The only one I can see there with a positive gradient and a positive y-intercept is this one here, graph D. The next one, minus x cubed. It's a cubic, x cubed. It's going to bend twice. There's no number here, so I also expect the y-intercept to be 0 for it to pass through the origin 0. And the graph that does that bends twice and goes through 0, is graph C. For those who are a little bit more on the ball here, you may also spot it because it's minus x cubed, it's kind of coming down rather than positive x cubed, which would grow upwards, like that. The next one is x squared, so this is a quadratic. Again, there's no x's in there, but the important bit is that power on that one, x squared. But I do have a number on the end, minus 3. So this time I'm looking for a quadratic curve, a curve that bends once, but with a y-intercept of minus 3. Let's have a look for it. And there it is, bends once and cuts through well. That could easily be minus 3. And then finally, y equals 3 minus 2x. Again, this is another straight line. The only difference between him and him is the number before x here is 2, suggesting a positive gradient. The number before x here is minus 2, suggesting a negative gradient, which is graph B. Moving on, let's do a couple more together. Ignore these. Okay, I'm looking at this, I'm thinking, right, okay, it bends once, so I'm looking for an x squared. If it was this way around, I'd be looking for a plus x squared, but because it's this way, I'm looking for a minus x squared. I'm also looking for the y-intercept to be 7, so maybe something like minus x squared plus 7, minus x squared plus 7, which I can see is there. Now, you could quite easily have made the mistake of going for this one here by going, oh, it's a quadratic with a +7, and I could see that being an easy mistake to make. This, for me, goes into a little bit too much detail. It relies on knowing the difference between positive x squared, again, which would be that, and this one, which has got the minus before the x squared, which kind of flips the direction. Probably a little bit too much detail in that one for me. Okay, whereas this one, we've got this curve passes through 1, and we identify that as our exponential. Y equals 2 to the power x. It's just one you've got to know. Down here, we've got our cubic with a 0 intercept. Y equals x cubed. We've got this one that doesn't touch the y and x axis and is in 2 parts. Okay, which is y equals 1 over x, our reciprocal. And we've got C, which bends once, so it's a quadratic with a positive y-intercept, so x squared plus 3. Sorry, I was meant to put letters. U are B, U are C, and U are A. Moving on. Quite nasty here, this one, again. Could this be this, is what the question is, true or false? Could it be? Well, minus x cubed, that's exactly what I'd be expecting for a minus x cubed, is to come that way and bend twice. Passing through here, could that number there be minus 2? Yes, it could. True. This one's coming from the other direction rather than coming down. It is starting going up and continuing going up, so I'm looking for an x cubed. Tick. But I'm also looking for a y-intercept that's positive there, but there is no number here. If there was some, say a +3, +4, +5, something there, I'd be going true. But this suggests a 0 y-intercept, which it is not. False. Ah, nasty. Anything to the power -1. Well, we know that negative indices mean 1 over, so another way of writing this is 1 over x, and that's exactly what that is. True. And here, I'm looking at an x cubed with a 0 intercept. What I've got is an x cubed with a +4 intercept. False. Last one of these, I'm looking for an x squared, not a minus x squared, but a positive x squared, also with a positive number after it. Y equals x squared plus 3. Okay, let's start drawing some of these. Starting with this. Here, I've been asked to draw the exponential curve y equals 2 to the power x. Anytime I'm drawing any graph, I draw a little table. I pick some x values, okay, off the x-axis. I put them in instead of x into the equation, and I work out the y values that will go with them. So I've done here 2 squared, which is 4, 2 to the power 1, which is 2, 2 to the power 0, anything to the power 0 is 1, 2 to the power -1, which is 1 over 2, and 2 to the power -2, which I'll just explain that. 2 to the power -2 is the same as 1 over, that's what the minus means, 2 squared, which is 1 over 4. Draw these points and I get this exponential curve, and then I'm asked to use the graph to find the value of 2 to the power 1.4. Well, 2 to the power 0 is that, 2 to the power 1 is that, 2 to the power 2 is that, but 2 to the power 1.4, which is about there, I've gone up and across and got 2.5. Or the flip of that is saying, what number would that x need to be to give me an answer of 1.4? So I'm looking at my answers here, coming back along and down, and the answer that would have given me that, I get about 0.5. Again, depending on your curve, you may be out by a decimal point to me, but as long as you're in these ballparks and you've used the graph, you're good to go. Okay. You're going to need to look at this, guys, because when it printed, it wasn't clear to see where the minuses were, so I've put in the minuses where there should have been minuses. The other thing that I've done here is I've worked out what y needs to be when x is 3. This was a gap here. So y equals x cubed, so I've swapped that for a 3 cubed, squared, x squared, 3 squared, minus 5 lots of x, minus 5 lots of 3, plus 2. Worked it all out as -4. Okay, once I've got all these coordinates, -1, 8, 0, 2, 1, -2, and so on, I can plot them all, and I know what I'm looking for, because if you look at it again, it's a quadratic with a +2 intercept, which is exactly what I end up with, this quadratic shape passing at +2. Okay, notice that I've drawn the smooth curve, and then the final part of these questions often ask you to draw a line like y equals something. So in this case it was draw the line y equals -3. Again, it wasn't obvious to spot, it was -3. Y equals -3, so here's that line, and there are two places that are on the curve but also on the line. They are here and here, and the corresponding x values are this one and this one. Again, you might be slightly out to me, but that's what I get. Again, I'm going to stop and take a little bit of time on this one. Okay, again, apologies that some of those minuses didn't come out, but what we're drawing here is y equals 2x squared minus 5x minus 1. I'm going to start by working out the missing number here, okay, by when x is 2. What is y when x is 2? So what I've done is instead of 2x squared, I've written 2 times 2 squared minus 5 times 2 minus 1. Bit awkward here. BIDMAS tells me that I'll do this bit before I times by 2. So 2 squared is 4, 2 times 4 is 8, minus 5 lots of 2, so minus 10, take away 1, 8 take away 10 is minus 2, take away another 1 is minus 3. I've started putting these points on, so let me put minus 3, minus 1, minus 2, minus 3 is about there. Okay, and then this one a little bit harder because of the negative. 2 lots of minus 1 squared, minus 5 lots of minus 1, look, I've swapped x for minus 1, and then take away the 1 on the end. Minus 1 squared is 1, minus 1 times minus 1 is 1, then double it, that's 2. 5 times 1 is 5, but that's negative, and it's times in a negative, so that's positive. 2 plus 5, take away 1, is 6. So when x is minus 1, y is 6. Okay, I'll scroll down. I'm now able to hopefully connect these up, but this won't look so great because I'll do it freehand. Okay, you take your time and possibly make sure it's neater than that, but there's your quadratic curve. This time I'm asked to draw the line y equals 5. Get my nice pink ruler out. Y equals 5. And again, identify these x values where we're on the line but also on the curve, which is there and there. So I get approximately minus 0.8 and 3.5. Okay, I'm going to shift from there. Again, I'm going to leave this one blank and for you to have a look at. I've started you off, okay. Possibly the one I will do, you can fill in the gap there for 2, but I'm going to fill in the gap for minus 2 because it's a little bit nasty again, because yet again we're squaring, we're multiplying with negative numbers, horrible. But x squared, if I'm swapping x for minus 2 squared is minus 2 times minus 2, which is positive 4. Then I've got 4 times 2, which is 8, 4 times x, which is 8, but plus 4 times minus 2, a plus times a minus is a minus, and then minus 1. 4 take away 8 is minus 4, take away another one is minus 5. You do the same, but swapping x for 2. Alright, and try and follow them. Once you've got all these coordinates, plot them, you should get that nice quadratic curve again. And that one should be okay for you. Let's move on to drawing a cubic graph. Okay, 4 lots of x cubed plus 10. Again, there are some kind of missing minuses. That's minus 98, whereas these two here, apologies you couldn't see this, that's plus 6 and plus 10. Minus 3, minus 2, minus 1, and so on. 1, first of all, 4 lots of 1 cubed plus 10. Well, indice first, 1 cubed is 1. 4 times 1 is 4, add 10. 14. Okay, and minus 2. 4 lots of minus 2 cubed. Again, a bit harder now, but think this through. Minus 2 times minus 2 is 4. Times minus 2 again, and like the quadratic, the squared, which makes it positive, if you then times it by itself again, it returns to a negative. So minus 2 times minus 2 is 4, times minus 2 again goes back to minus 8, right? 4 lots of minus 8 is minus 32, add 10 is minus 22. I've started putting these points on there. I need to put these extra ones on, so minus 22, and when x is 1 we get 14, which is approximately there. It's hard to get this perfect. And there's that. Sorry about that point. Made a bit of a mistake there. Let me move that up. Apologies. Couldn't even see that then. And that's what we're getting. Okay, we're asked to then work out the value of x, for which 4x cubed plus 10 equals 60. So what we've done is we've swapped, instead of y equals this, we've swapped the y for 60. So where is the answer to this graph? 60. Well, the answer to the graph being 60 is there. Effectively, I'm drawing the line y equals 60. And again, I'm not quite perfect there, but about 2.4 maybe. Okay. We are going to move on to straight line graphs and inequalities in the next video. I haven't got as far as I would have liked, as is my normal, but hopefully we can pick up speed now with these and get through this booklet. So there's the first question on straight line graphs, but I'll go through those again in part 2.